Joey Vega. I actually, as well, on my screen, you see Jose L. Vega, Jose Luis. I'm known in a couple different ways, so sorry for the confusion. Um, you can call me Joey. So I'm going to be your engineer for today's lesson. If you were in yesterday's session at some point, you might have heard that teaching is much like engineering. We have criteria, we have constraints. So it's really important to kind of remember that and reinforce those ideas. So some of the criteria that I have for this lesson, right, has to do with focusing on NGSS, has to focus on specific tools to be able to use in your engineering process. Um, Also, that we do a little bit of participation here, right? So we'll do um, some chat contributions. We'll get into a breakout room a little bit later. Some of the constraints you probably feel yourself here. Time, right? These are pretty short sessions for complex ideas and tools. So you're going to get brief introductions to things. You might be left with questions that we hopefully can answer or you can send our way afterwards. Um, Another big constraint is that we're on Zoom, right? So we'll do our best and really structure this in a way that's best for everybody here. So brief introduction on for myself. I'm a lifelong educator. I've always taught science. I've done middle school. I've done high school. I've done science coaching in elementary, um, public and private schools from California. Most recently, I was in Colombia, in Medellin for 7 years, and I'm currently at a boarding school in California, just south of Santa Barbara, and I design experiences around social emotional learning and residential life currently. But one of the things that I've done for as far as I can remember is really think about how in terms of instruction. So today we're going to be looking at how we can really look at some structure around engineering and engineering design. So let me jump on, have everyone jump on my screen here. John, can you allow me permission to share my screen? I have John Mark as my assistant, so he's definitely helping me out. So, all right. All right, thank you. So here we go. So I've simplified our look here. We have pretty complex issues to look at, and so we're going simple. So we're going to be looking at empathy for engineering, and I'll explain what that means. Some of the guiding questions that I'm using, obviously we mentioned how we teach engineering. This is what these 3 days are about. What framework or frameworks can we use to structure our lessons, our challenges, or units? Really our student experiences and student learning. How can I embed tools in my teaching in order to help my students deepen their understanding of their learning? Specifically today, we're going to be looking at defining problems in order to deepen student understanding there. Okay, so we're sharing framework and we're applying something called empathy mapping. That's a strategy that we're going to be practicing today. We're going to be sort of simulating using that tool a little bit in our time constraints here. So first, I really want to know a little bit more about where we are all at as teachers when it comes to engineering design. So I want everybody to jump in the chat here in a minute. So how would you define engineering process, or what words or phrases or thoughts come to mind when you hear engineering or design process? What challenges or perceived obstacles are there in engineering design? Or you can also throw out, when was the last time your students experienced design engineering with you? Or what's the next time students are going to be facing engineering? What's on the plate coming up here? So you can answer any one of those questions. So let's take a moment, throw it in the chat, take a look at answers when they come out. So what comes to mind? What are some challenges? What's next? What was last? All right, thank you, Heather. Iterations, testing, refining. Many students are going to be designing a calm corner for first grade. Awesome. Engineering sounds very complicated. Awesome. Some nice physics can be added to that. So patience with process. Okay, making it broad enough to be open-ended. Yeah, there's kind of like a Goldilocks range. Not too much, not too little when it comes to a lot of what we do here in design and engineering. Yeah, and for some, engineering is just coming to your school, right? It's a newer process, a newer methodology, newer expectations. So we have to reorient ourselves a bit at times. Some words: creativity, collaboration, problem solving, perseverance. Absolutely. All right. Thank you for that. So we're also going to be operating on some assumptions. Okay. So I'm going to talk through some of the things that maybe already happened, have happened, and are currently in process, right? So I'm going to assume that we might have a pretty good concept of the three-dimensional framework of NGSS. For some of us, it might be brand new, but we're talking about the practices, the science and engineering practices, the core ideas, and the cross-cutting concepts, right? You probably saw a lot of that yesterday. One thing that I think is also very important that Paul Anderson was talking about yesterday is the connection between science and engineering, right? When teaching science, we are answering questions. We're answering questions around phenomena, right? We're using an investigative process, an inquiry process, very much connected to engineering. But engineering, however, is really thinking about the human needs, which leads to a design process, which we're going to focus on today. A third assumption is that you're becoming familiar with some of the standards around engineering, which are embedded in performance expectations, um, which you might have seen. So here are three out of the five. So defining some engineering problems, developing possible solutions, and optimizing the design solution. We're pretty much going to focus on the very first one today, defining and delimiting engineering problems. Also, you might be working across grade levels. You might be working at a K-12 school. You might be collaborating within a department. So there's a progression, right? I think you definitely dived into that yesterday and are probably still thinking about K2 expectations versus 3-5 and beyond, right? We might have some people here working in middle school, working at different levels. So a couple more assumptions before we move on. Some of you may have already chosen a curricular framework that's very much needed. How do we structure learning? How do we structure our instruction around design? What resources can I use? And obviously, these 3 days are meant to enhance that as well. Using problem-driven design to frame the learning. So really in engineering, we're looking at problems. So hopefully we can frame everything we do around that, but also have some voice and choice in that at times. Hopefully we've anticipated and defined some of the student need to knows, which are a lot of the logistical aspects that students ask questions around in terms of time, groups, materials, limits, restrictions, right? Hopefully have made some appropriate decisions around each phase of whatever design process we have chosen. The very first one that I started using a number of years ago is here on the right. I don't see it as much anymore, but this is typically what I use both in planning, and I also use this with students when they began to work on the number of these phases. And also the last assumption here is that you figured out a way to really embed science throughout the process. So have you started with the phenomena? Have they already learned the key concepts necessary for this work, or are they going to do that in parallel to the work for the engineering as well? So this is one that's used as well, the engineering design process. I kind of want to know what's out there. I'm going to show you a few in a little bit. I'd love for everyone to use the chat again real quickly, answer in the chat. So what helps you structure NGSS engineering? What framework do you use? Or what's something that you've heard about, maybe haven't used? Because that's part of our work today as well, exposing you to some new ideas, some new structures. So what have you used? What are you using? What are you hoping to use? If we can quickly throw that out there in the chat. What's your campus using? What are their science teachers using? What's familiar to us? Do we have anything at our disposal to structure NGSS for our students? Okay. These are PYP units of inquiry to try to give the NGSS context. Yep, absolutely. Okay, so as we think about those, as you throw those out there, let's see, mystery science in elementary school, ask, imagine, model, create, test, improve, and share. Awesome. Let's see. Tony creates his own structure, and that's okay. Modifying is really one of the things that we have to do. We have to take from others and adapt, and that's really what I'm hoping that we all do. Design thinking, awesome. I'm going to mention that today. We might actually be using. We're going to be using a little bit of design thinking today. Stanford D School. Okay, nice. The 5 E's, absolutely, absolutely. That should be one. That should be a great starting point as well. Okay. All right. Thank you for that. So this next slide, this is what it looks like to explode my toolbox. Okay, so take a moment, take a breath here. There's a lot on the screen. Okay, I'm just going to briefly kind of talk through some of the tools that are used when I have a plan in the past for engineering design. I usually start with project-based learning. I think Britta actually today is going over that or has gone over that, or maybe some of you came from that. So I start managing my plan, my unit plan, with the essential elements of project-based learning. I think it's comprehensive. It provides a lot of areas for student independence. It provides a lot of comprehensive work around the roadmap that we need. So I start with standard-based, with with the project-based learning. When I think about content and using ideas, generating ideas for students, I sometimes use the United Nations Sustainable Development Goals, or the SDGs, which you see up here in the top right. Some of you may be familiar with them. One of my favorites that is not that well known is called Systems Thinking. It comes from Compass Education. It's specifically geared for the classroom. And I've used it for a number of years. I've trained with them, facilitated with them, and it's one of my favorites, and they can be used in a number of different ways at different times. Today, we will be using design thinking. It was also one of the first ones that I jumped into a while back. That can definitely provide a little bit of everything for us, some student voice and choice, some sustained inquiry. That can help us with the problem and the question. I also have used National School Reform faculty for feedback protocols. As students become older, we want them to become more independent. We don't want the entire engineering process to be teacher directed. We don't want students to rely on teachers for feedback solely. That becomes really difficult and unsustainable for teachers to be the sole place for student feedback. Obviously, it's part of our responsibility, but as students get older, we hopefully embed some protocols to help them give each other feedback. So these are some of the tools and structures that I use in general when it comes to design and engineering with students. Here's another one. So typically when I show students their process, I'm going to use something like this. So I try to simplify. There's still a number of steps, but we're going to be looking at the first 1 or 2 steps here. We're not even going to get as far as brainstorming today because there's a lot there. So real quickly, you probably already looked at this. We're not going to spend a lot of time on this, but with the progression, here's our focus for today, right? Defining and delimiting engineering problems. Okay, this is what's going to be our focus today. We're going to be asking questions, making observations, gathering information, helpful in thinking about problems. In the upper progression, we're going to really have to think about criteria and constraints. And the tool that we're going to be using today is going to hopefully help students be able to surface some of those and find some of those constraints and criteria. So design thinking, I think I saw two of you said that you've used this before. This is kind of a dynamic collaborative process that can be used in a couple different ways. You see that there's ends with prototyping and testing. So it lends itself quite well for the design process, the engineering design process. So before really beginning with solution, I don't know if your students are like mine, but if I mention a problem, their brains automatically start throwing out some solutions, right? We need to sort of build a culture around digging in and diving pretty deeply when it comes to understanding a problem first. So that takes structure so that we can build a culture around that. So we're going to be using the first step and potentially the second here in design thinking so we can better define a problem and really understand it beyond the superficial. And we're going to call that empathy mapping. Okay, before we get to that, we're gonna watch a 2-minute clip. Okay, this is going to help frame some of the work that we're going to do here in a second in breakout rooms. So hopefully, let's see. I'm going to make sure that I did optimize it for sharing. So let's go back to our video clip here quickly. Okay, so we have a quick clip that's going to help frame some of the work that we're going to do in a bit. All right, so hopefully they didn't make or break my reputation by showing that Larry David clip. Let's hello, sorry about that. Whew. All right. You all saw the clip, right? Okay, I got lost in my own clicks here after all this. So hopefully you're observing. He was the user. The user is somebody that's impacted by the problem. Okay. um, there are clear needs. There's a lot of insights by being able to observe in those 2 minutes. Okay, so here's what I want real quickly in the chat. Even if it's obvious, a few of you, what was the problem? How do we state the problem there? What was the problem? Somebody go ahead and state the problem, even if it was obvious. And we also have different perspectives, so it's not always maybe that obvious. Okay, how do you safely remove an item from the plastic packaging? Safely, right? Bad packaging, opening the package, horrible packaging. His needs to open the package, okay. Yes, didn't have the right tools. That's another consideration, right? Didn't have the right tools to open the package. All right, without checking the options first. So we observed Larry, okay, first name basis. If we could interview him, what questions would we ask him about the experience to learn more about this problem and his needs? So let's get a few people just to throw in the chat. What questions would we ask him about the experience to learn more about his needs and the experience? Hurry, so time, scissors, talking about the tool, what tools do you have available in that room? Which tool did he like the most? I like that. What was in the package? Why did you choose to use the knife? Why didn't you ask for help? Right? We might be wondering other questions as well. If we had to survey other people that have this problem, right? We could do that. What else is needed to learn how to improve this experience for him and other people like him, right? These are the questions that we might ask ourselves in learning about a problem. So this is really thinking about empathy when we start to dive in with observations, questions in interviews, potentially surveys, maybe doing some traditional research about the package itself, about the process, about the tools used to open packages. So really going back to design thinking and empathy, we're going to be using empathy to understand the problem at a deeper level. Okay, so I already mentioned some of those techniques: observing, interviewing, surveying users and stakeholders, right? So the user was Larry. He was experiencing the problem, but there are other stakeholders involved. They could be the people creating the packages, the people marketing for the packages, the people creating the tools that are needed for packages. Okay. This is going to help us lead to define the problem. So when we get into the upper grades, so 3 to 5 progression, they're going to be expected to really be able to define the problem, potentially in a how might we statement. So up here or here at the bottom, it might help frame the question, how might the product packaging be redesigned to? And in this space, can really create a focus in terms of a solution they might need. So it could be so as to reduce frustration, to not need any tools involved. So the solution is really going to depend on sometimes how to finish that. How might we? So to be able to look at one of the tools that we're going to be using next, I want you to imagine the following. So let's pretend that here's the problem. Might sound familiar to your school, might not. So students notice that a lot of recyclables end up in the trash cans at school, and they want to increase recycling. Okay, that's the problem. So a group of students, not really talking about how the process or what process they used to get there, but they came up with a solution. So let's say after a short meeting by the green team, one student convinced their parents to buy several recycling bins with specific shapes in the lids, as you see pictured there. It was costly up front, but the school was happy for the donation, right? After a few weeks of monitoring, the students noticed that there was actually no change in how much recycling ended up in the recycle bins versus the trash can. Okay. So imagine that scenario, that problem, that solution. Okay. So we're going to be now using a tool. Um, it does come from, some of these techniques come from design thinking. We're going to be mapping it to be able to be visual with our students. So I want you to start thinking about some of the work that you do with your students and where this might fit in, because that's where we're going to go. So here's your task. You're going to simulate completing an empathy map in a small breakout room around the previous recycling problem, right? They want to increase recycling, reduce the amount of recyclables in the trash. They came up with a solution, right, which was in the picture. And you're going to, in a small group, we're going to share the link to these slides, all of these, and you're going to have access to them, be able to edit it. You're going to go to the number corresponding to your breakout room. So if you end up in breakout room 5, there's going to be a slide. I think it's at the bottom right of this. It's going to say slide 5. And your group is going to work there and actually edit. And I'll show you exactly what that looks like in a second here. So you're going to navigate there. You're going to add what the user says, what the user thinks, what the user does, what the user feels, and pains and gains refers to challenges and successes. Okay, we want to make sure that we include voices from various people affected by the issue. Okay, so in that clip, it was Larry, but if it's recycling at school, right? Students, teachers, might be vendors on campus or external vendors, it might be parents, might be the business office, it might be the environment, right? It might be the local fauna in the area, right? Maybe there's some interaction there with the recycling not ending up where it's supposed to be. And it's going to look like the following. So here's a template. This is what you're going to see. Okay, so here's our example template. On the right, I have a little bit more detail. We're not going to go too much into here. You can do that when you get there. But we're going to pretend, that's why we're calling this a simulation. This really would come after observations and interviews and surveys and traditional research. But we're going to do it now. We want a short introduction without doing all of that. And so we're going to simulate different voices. So let's try that now. So it should look like the following. Trash can, recyclables, trash bins at your schools. Okay. What actions might we see? So now I'm going to go to the do, which is talking about actions. I'm going to take the student perspective. What actions might we see students, what behaviors might we see around either consumption of products and then discarding, trash, recyclables? Somebody go ahead and unmute, or even in the chat, like tell me, what could I type out? So I'm literally gonna edit directly here. What actions might I see? So we're gonna pretend, we're gonna simulate that we're students filling this out. Let's see, throws, yep. Maria Ruiz, thank you so much. Natasha Tooth. Okay, cans in the trash. Okay, so both of you mentioned cans. Okay, wrong bin, right? We can observe that, we can see that behavior. Okay, let's change the stakeholder, and I might label this student, right, just to kind of keep track for now. Let's do one more. So let's pretend I'm going to take the teacher perspective. Somebody tell me what a teacher might think, say, or feel, or even do when it comes to that problem and that solution. So what might that look like from the teacher perspective? No one reads, absolutely. So they might think that, they might say that, right? It doesn't matter exactly where I put it. How can we get students to be attentive? Absolutely, I like that sort of underlying thinking there. Um, if they're not reading, if they're not paying attention, how can we get them to be more attentive, right? That's kind of where it's going to lead to. They might think that they're lazy, okay? Um, concrete, I'm going to put that. So let's say it was a teacher might think students are lazy. Okay, so directly editing this doc is what we're going to ask you all to do. Okay, see, teachers are asking to use right bin, students don't know how the system works. Great. Okay, so I also, when you get into your breakout rooms here in a bit, I also want you to think about other people involved that might have to do with this empathy mapping. So are we talking, observing, interviewing, surveying vendors, right? That means people selling sodas at school or packaging of snacks? Or do we not have that problem at school? Is this a business school problem, a business office problem, because they're the ones that bring the vendors? Or is this a student-based problem? Or is this a teacher thing? So let's sort of change the perspective from the stakeholders and the voices. Um, parents sending luncheon, right? So we're gonna really look at all these perspectives here. So that was my example of us doing this together. So now I'm going to ask you all to do this in small breakout rooms around that problem and solution. John Mark is going to facilitate the breakout rooms. I'm also going to ask, is there any clarifying question that I can answer for anybody before you get there? Okay. All right. Go ahead and send me a message if you need me to answer anything. Otherwise, let's mosey on over to those breakout rooms and let's open up the slide corresponding to your room, please.
Mariette, Johanna, AM. Do you guys see a breakout room invitation? Awesome. Joey, this is going really well. So, from this map, does that help them formulate the how might we question?
Yeah, and I'm going to show them that afterwards.
Gotcha. So it's like I'll wait then.
Yeah. So lower grades, they really won't, it'll be hard for them to do that. Upper grades, like 3 to 5 are going to have to formulate the how might we question. So
Mhm.
I'm going to show them how this fits in, because the next question is, so I make a map, so what? Like, what do I do next? And that's
Mhm.
where I'll say it fits into the progression of making a how might we, to then be able to generate ideas for a solution around that how might we.
Cool.
Yeah, so that's part of the sequence. I literally got lost in my virtual space for like 20 seconds. I was like, after the
You
video,
recovered well.
yeah, after the video, I for about 3 seconds, I thought I had ended the Zoom session,
Oh no.
and I was like, okay.
No, you recovered very well. Yeah, I'm interested about framing the how might we question.
Good, good. Yeah,
I wish I'd done this engineering design project after this conference.
I love how might we questions. I mean, and there's usually like the two stages. You know, it's one that I throw out as a teacher, and then as students, they're going to rework a more specific focus of how might we.
Cool. Sorry, how long did you want them in there, by the way?
Let's say 8 minutes for this one.
8 minutes. All right. So at 43.
Yeah, I think the compass is a little bit easier to keep working on it. I think. Let's see here. So I've already mentioned some of the how. Like there's a little bit more of the detail. Field observations, interviews, surveys, mapping, and also traditional research. Okay, those are some of the ways that we can do that. This is what the template looks like, shareable. A lot of the times low tech is great for this. Obviously we're doing it here now, but I love to get a huge poster paper and have students work on it. Here's one that was done about paper use at school. Okay, so just kind of looking at a little bit feelings. Teachers have a lot of feelings, so do students, so they're all here. Let's see. Actions, only printing tests and try to provide the option of having a computer notebook. One of the pains kind of caught my attention, students plagiarize and cheat. I don't know what perspective that came from, but this was actually a student product. Let me show you one more with a lot more detail. So this one actually has surveys added to the canvas, right? Which is just a Google drawing. And so all around, potentially in upper grades, you can have them directly add this on here if you wanted it to be a digital version, right? So we have observations, we have statistics around interviews, observations, as well as the quotes and everything else captured. So this is one other option to show you. So you might be asking what you're going to do with all that information. So let's say you compile lots of information, right? You should be able to find needs and constraints within this. When thinking about design and engineering, what this leads to is something called a need statement or a how might we. I use a lot of how might we's in setting up projects and having students think about problems and solutions. So once I do an empathy map, you're going to ask them to try to find really what are the needs, right? The users are who's affected by it. It's like kind of like a Mad Lib. It might look like the following. How might the school, and these are for other problems, but how might the school redesign their purchasing practices so as to decrease their environmental impact, right? So as to is really important because that's going to ultimately guide their solutions later on, their ideas, their brainstorm. How might our city create healthier public transportation so as to improve air quality? Because so as to easily could be to save money, to be healthier, to be more convenient. So it could really guide what comes next. So after empathy mapping, you might do a need statement, especially for like grades 3 through 5. So here's a sequence of what it might look like. So we've already done a little bit of empathy mapping, okay? I briefly mentioned a how might we, okay, through a need statement, and this one's missing at the bottom here. Sorry about that, but it's a how might we. It's gonna focus our problem. It's gonna define the problem, okay? From here, the very next step of engineering would be, oh, I'm missing my next one here, is to ideate or brainstorm solutions for, for the problem that was defined. So you can easily see that you might have students take a step back if they've already come up with solutions to maybe empathy map first before they come up with all of those solutions or brainstorm. We don't have enough time to kind of go over this, but this is a very specific brainstorm that comes from design thinking, which actually has you encourage wild ideas. You go for quantity over quality at first, right? You start with an individual brainstorm, then lead to a group brainstorm to build on each other's ideas, which is really, really useful. So really from here, I mean, I kind of want to know, there it is. So I kind of want to know big picture, where do we go from here? What are the benefits? Maybe what's missing? How can you use it? How are you going to use it? How can you make this better? How can you modify it? How can you supplement? What are some final thoughts here or questions around what you've seen, what you've heard, really thinking about the empathy map, the steps that are involved, but also where it falls in the sequence. Identifying the problem with the need statement, and also generating ideas for brainstorm and solutions afterwards. Anybody have some final thoughts, final questions, final ways to see it, final ways to improve this potentially? Let's see, John Mark, should we always be a group or institution that students belong to? That's a great question. I love a collaborative approach, and I find that we typically helps us get there. And you also want to define the we, right? A lot of times, like, who are we talking about? So I love the we, sort of collaborative and systemic in model versus like, oh, this is on me. I have to do something. I like Natasha, I like the idea of interviewing and surveying to help define the problem, but it's more of a challenge when it's an invented problem. Yep, good point. Let's see, Marcela, the empathy element is what hooks us to the process and connects us to deeper thinking. Yeah, thank you for that. And that's obviously one of the goals.
Nidia has her hand up.
Oh, sorry, Nidia.
Thank you. Sorry, I'm on my phone and it's a little hard to write on the chat. I think one of the many challenges here, and for me specifically, is students coming up with a lot of ideas, and we always tell them all ideas are good. But you know, you're talking about insecurity, and they say, "Oh yeah, let's build a drone that attacks the bad guys and catches them." And you know, and it's like, okay, calm down and let's first analyze the problem. So I guess that's awesome, but at the same time, it's a challenge.
It takes time because you have to build a culture. And sometimes you start smaller, you set the expectations, you do the practices, you reflect on that experience, and then you come back again with a little bit wider of a scope, maybe a little bit more involved. So absolutely, and it takes time to build a culture, but that's a great point. They get excited, and it's hard to pull them back sometimes. Awesome, folks. Well, it's 3:56 my California time, later for you. I really appreciate this time. Hopefully you took something away from that. My contact is at the bottom of this, of my slides, which you have access to. I'd love to have more time to answer questions. There is a chat and chill later with me. But otherwise, I'm all about this work, so please contact me if you have any questions. Have a great afternoon. Have a great night.
Thank you. Thank you.
Thank you.
Thanks, Joy.
Thanks.
Thank you.